Hello and welcome back to Creativity in Coding Camp. My name is Amy. I'm another one of your VEX Camp counselors. And I'm super excited to be here right now because now that you've learned how to code the VR robot to go to an exact location using the coordinate grid, you are ready to be introduced to a couple more of the VR robot's amazing features. So we're going to learn about the electromagnet in this session, along with the eye sensor. And what we're going to do is learn how to code those and put that information together with everything you've learned so far to complete the Disc Mover Challenge. Let's get started. So an electromagnet is just a type of magnet where the magnetic field is produced by an electric current. And on the VR robot, it's right here in the front, as you can see on the poster. Pointing down so that it can pick up discs. Let's take a look at it on the robot itself. So here is the electromagnet on the front of the VR robot. I just switched my view so you could see the robot here. And what this electromagnet can do is pick up discs with metal cores. And here's a picture of what those discs look like. All right, so if you don't have VEX Code VR open, go ahead and open it up. We are going to get started with a new blocks project, and the playground we're going to select is the Disc Mover playground. So go ahead and get that ready and then open up your playground so you can code along with me. So what we're going to do in this first challenge is code the robot to drive up to this first blue disc, pick it up with the electromagnet, and then drive back and deposit it in this blue goal. And there are 4 behaviors we are going to need in order to make that happen. And what we're going to do is make some comment blocks to keep our code organized. We're going to put each behavior into a comment block. So the first thing we need the robot to do is drive to the blue disc. All right, let's attach that on there, and I'm going to scooch this over just a bit. The second behavior we need to do, and go ahead and make your comment blocks as I'm making mine. The second behavior is for it to pick up the first blue disc. Then what we're going to need to do is drive in reverse back to this goal. So drive in reverse to the blue goal. And we are going to need to drop the disc in the blue goal. I'm going to say the first blue disc into the blue goal. Okay, so now I have my comments here that are organizing the behaviors that I want my robot to complete, and I'm ready to start coding. So the first thing I want to do is get my robot to drive from where it is now up to this blue disc. Now what we can do is use a drive for block. So I'm going to go to the drivetrain category and bring my drive for block out. But I need to figure out how far my robot needs to drive in order to be in position to pick up this blue disc. So one thing I know is that each square on this grid is 200 millimeters squared. So 200 millimeters across. So I'm going to count by 200s to see how far I need my robot to drive. So 200, 400, 600, 800 millimeters. Now, keeping in mind that the electromagnet is in the front of my robot, I may not want it to go all the way to 800 millimeters before it picks up the disc. I don't want it to overshoot the disc. So I'm going to take a little bit of my measurement off. We're going to say 750 millimeters. So I'm going to have my robot drive for 750 millimeters. And that will be my first behavior. So let's go ahead and test it. All right. Yep, that looks just about right. Great. Okay, so now I need my robot to pick up the first blue disc. So what we need to know now is what block are we going to use to do that? So we're actually going to go to this magnet category. And we've got this Energize Electromagnet block, which we're going to drag out here under my comment. And it says Energize Magnet to boost. So boost means it's going to pick up that disc. So now we've told the robot to drive to the blue disc and then to pick up the first blue disc. Let's see what we've got here. Yep, we did it. So our first 2 behaviors have been completed. The next thing we need to do is drive in reverse to the blue goal. So I can basically pick or take my block that I have here and duplicate it. Now, of course, it's going to duplicate the whole stack of blocks. I only need the drive for blocks, so I'm going to throw the rest of them away. And then I'm going to put this where it belongs and change my direction to reverse. Okay, third behavior, drive in reverse to the blue goal, has been coded. So let's test our project again. There we go, picking up the disc, driving back. Great, we're doing great. Okay, now all we need to do is code the robot to drop the first blue disc into the blue goal. So we're going to use this energize electromagnet block again, but this time we're going to change boost to drop. So it will deposit the electromagnet. All right, so you have just done your first coding of the VR electromagnet. Let's run our project and see if we've achieved our first goal. There it goes, and brilliant, we did it. Okay, so now that we've coded our robot to pick up and drop off one blue disc, let's try to code the robot to pick up all 3 of the blue discs and drop them off into the blue goal. So looking at the project we've already built, we've already coded the robot to get that first blue disc picked up and dropped off where it needs to be. And we can use the blocks that we have to help us get to the second blue disc. So what I'm going to do first is just duplicate what I have here, including my comments. And I'm going to change my comments to reflect this next set of behaviors. So now I want to drive to the second blue disc. Now I want to drive to the second blue disc. And then I'm going to pick up the second blue disc. So I'm just changing my words here so that keeping my project organized. All right, now that we have our comments, we can change our code blocks. So the first time we picked up a disc, we drove forward and reverse for 750 millimeters. So we can again use what we know about the grid map here and count by 200s to see how far we're going to need to drive. So 200, 400, 600, 800, 1,000. This is 1,200 right here. But again, I want to make a little space for the electromagnet. So I'm going to take 50 millimeters off of that measurement and put in 1,150 millimeters for driving forward and reverse. Okay, so I have the same pattern here, right? We're driving forward, we're energizing the magnet to boost, we're driving in reverse, and then we're dropping the disc with the electromagnet. Same thing again. Okay, so basically I've repeated the same behaviors, but just changed the parameter here. Let's run this and see if we now have created a project that will pick up the first 2 blue discs. Got that one. And now, yep, got the second one. Brilliant. Okay, so what do you think we need to do to get the third blue disc? If you are thinking the exact same thing and just change the parameters, you're right. And I just noticed a typo right here, so I'm going to fix this. So it looks good. There we go. Okay, so again, I'm going to duplicate my blocks, attach them to the bottom of my project, and count to see how many millimeters I need to put into my parameter. So we've got 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600. It's taking off 50 millimeters to give a little space for the electromagnet. So we've got 1,550 millimeters. Okay, and of course I'm staying organized, so I'm going to change my comments. Looks like something's a little off here, so let's check and see what we've got. Looks like I'm missing one comment here. So let's get this comment out, because right here is where I am now driving forward to pick up the third disc. So drive to pick up the third blue disc is my comment. There's my block. Pick up the third blue disc and drop off the third blue disc. All right, I have quite a long stack of blocks here with all the comments, so I've made them a little bit smaller so you can see the whole stack. Let's reset our playground and run them and see if we've achieved our goal of getting all 3 of these blue discs picked up and dropped off into their goal. There's 2. And 3. Fantastic. We created a project that coded the VR robot to drive, pick up, and drop off all 3 blue discs into their goal. So now what we're going to do is learn how to code the VR robot to pick up and drop off discs in a different way, and this time we're going to use sensor feedback. So what we're going to do is start a whole new project. You can save this project if you want to share it with somebody or open it up later, but I'm going to do new blocks project and get my Disc Mover Playground back up here. And I'm going to make those same 4 comment blocks that I made when we started our very first project. So the first one is going to say drive to the first blue disc, because what we're going to do is do the same project but in a different way. So pick up the first blue disc. Oops, let's make it capital. Pick up the first blue disc. Next up is drive to the blue goal. Whoa, I better type a little slower, huh? Drive to the blue goal and then drop the blue disc in the blue goal. All right, I've got my comments and now I'm ready to start coding my behaviors. All right, so code along with me here and then I'm going to explain to you what's happening with the code. So we're going to go to the control section. We're going to grab a repeat until block, one of these C-shaped blocks, and attach it to our first behavior, which is drive to the first blue disc. I don't want these comments inside my block, so I'm going to connect them to the bottom instead. And then I'm going to go into the sensing category, and I'm going to get this block, and I'm going to put this Boolean reporter block right into this C block, the C-shaped repeat until block here. And I'm going to change this to down eye because like we said, we're going to use the down eye sensor to detect the discs. Okay, the next thing I want you to do is go into the drivetrain blocks and grab a drive forward and put it right there inside that C block. And then we're going to grab one more block, which is the stop driving block, and put it underneath there. And so we've coded our first behavior here. But let me explain to you what's actually happening. So what's going to happen is the sensor is going to repeatedly check. That's with this block right here, this repeat until block. The sensor is going to repeatedly check to see if it detects an object over and over again. And as long as it does not detect an object, it's going to do whatever's inside this block. In this case, it's drive forward. So the robot is going to drive forward until the down eye sensor detects that there is an object there. Once it does detect an object, then the robot will break out of this loop and go on to the block that's underneath, or whatever blocks are underneath. In this case, it's the stop driving block. So let's watch it run. All right, so it drove forward. The sensor was checking to see if it was near an object. It was repeatedly driving because it didn't detect an object. Then the second that it did, it broke out of the loop and the robot stopped driving. So that is our first behavior. Now we still want the robot to pick up the disc with the electromagnet, so we can attach that block right there. And let's check our project. Got it? All right. So the next thing we need to do is drive to the blue goal so we can deposit the disc. Now, when we did this project before, we needed to drive in reverse for an exact distance to drop off the disc. But we don't always have the ability to measure or calculate exact distances. So using sensor values to tell the robot where to stop driving in order to drop off the discs can be really useful. So what we're going to do is use the distance sensor for this task. The distance sensor measures the distance from the front of the VR robot to the nearest object. And what we can do in this case is use this back wall here of the playground as the object that the distance sensor is using. But to do that, we need to turn our robot around so that it's facing that back wall. So what we're going to do is go into the drivetrain category, and this time we're going to get out a turn to heading block. And let's just put it there for a minute. So the turn to heading block is really useful because it allows us to turn the robot to a specific heading no matter which direction it is pointing on the playground. So if, for example, the robot is driving and it bumps into a disc and it gets slightly off track, we can be 100% certain that if we use the turn to heading block, it will turn to the exact heading we want it to go to, which in this case is the back wall. And we can see here from our diagram that the back wall is 180 degrees. If we wanted our robot to go straight forward towards the disc, we would choose 0 degrees. All right, so since we want our robot to face the back wall, we are going to add our block right there and change our parameter to 180 degrees. And let's just test our project so we can see our robot make that turn. And there we go. All right, fantastic. Now we're ready to get the distance sensor in on the action. Okay, so just as we did before, we're going to go into the control section and get another repeat block, repeat until block. And again, this is going to allow us to use sensor feedback from the distance sensor to tell the robot where to stop. So we'll go into the sensing category and we'll get one of these blocks here, and then we're going to get an operator block to put this oval shaped block into. Going to grab the less than block, put it right there. This fits beautifully right into here, and let's move this over. Okay, so now you can see. All right, so drag those blocks out there and then get one of our drive for blocks or our drive blocks. Okay. So we have something similar here as to what we have up here, right? We have this repeat block here. We have a loop happening again. And let me add one more block to the bottom, which is going to be stop driving again. So we've got another repeat loop here. And what we're telling the robot to do is for the distance sensor to continually check how far away it is from this back wall until it gets a certain distance away or less than a certain number of millimeters away. Now 50 is probably too close to the back wall. Let's change this to 100 millimeters. So this way the distance sensor will drive forward until it detects that it is less than 100 millimeters away from the wall, and then it's going to stop driving. And you know what? If we look at our grid map again and think about how each of these blocks is 200 millimeters wide, 100 millimeters makes sense. So we're going to go with that. So what's happening in this block? The robot is going to drive forward, and it's going to continually check over and over again. Am I less than 100 millimeters away from the wall? Am I less than 100 millimeters away from the wall? And as long as the answer is no, it's going to keep doing what's inside this block. It's going to keep driving forward. But the second the distance sensor reports, yes, you are less than 100 millimeters away from the wall, it's going to break out of the loop and it's going to go right to that stop driving block. All right. So let's run this part, and then if it's working, we can use our last block here for this behavior. All right, we've got our disc. Distance sensor is detecting. Yeah, it stopped driving pretty much in the perfect location. So the last thing we needed to do is drop off that blue disc so we can get our energized electromagnet block here. Change this to drop. And we should be in business. Okay. And you know what? I am just going to fix this a little bit because if I'm looking at my comments here, this comment says drop the blue disc in the blue goal, but we need to have this up here with this comment, drive to the blue goal, because right here, the robot is still driving. So let me just fix this up a little bit so my comments and my code align. Okay, that looks a lot better to me. So we did it. We have created this project using sensor feedback for the robot to drive, pick up the first blue disc, and bring it back to the blue goal. Fantastic. We've learned so much in this session already. We've learned how to code the eye sensor, how to code the electromagnet, and we've learned how to use sensor feedback to help us pick up and drop off the blue discs on the Disc Mover playground. So the next thing we're going to do now is try to do exactly what we just did, except for all 3 blue discs. So we're going to have the robot use sensor feedback to pick up and drop off all 3 of the blue discs. If you haven't done so, go ahead and save your project so that you don't lose it and you can use it in the future. I'm going to name mine Electromagnet Mania. And I'm going to save it to my device. All right, so my project is now saved. Okay, so what if we wanted the robot to use sensor feedback to get all 3 of the discs? Well, as I'm looking at this project, and I'm going to run it one more time while I'm talking, I basically need the robot to do the same thing 3 times. All right, so now I need my robot to pick up all 3 blue discs and bring them back to the blue goal using sensor feedback. Now, one thing I want to mention is that sometimes it's very useful to set the drive velocity a little bit slower when we're trying to pick up discs off the Disc Mover playground, because that gives us a better chance of our sensor feedback reaching the robot in time. So sensors report back to the robot very, very quickly, but not instantaneously. So sometimes your robot might not pick up a disc because it hasn't quite had time for the sensor feedback to reach the robot's brain. So in order to make sure that doesn't happen, what we're going to do is get a set drive velocity block and put it at the very beginning of our project. And I know you learned earlier that 50% is the default velocity. We're going to slow our project down now to 25%. Okay, so we basically need our robot to repeat the same behaviors 3 times in a row to get those 3 discs. But before we do that, we need to think about giving the robot a little bit of space to turn around at the end. So let me run this project again so you can see it. Here it is a little bit more slow because we've set the drive velocity down. All right, so we've gotten our disc and we've placed it in the correct blue goal. However, we can see by the positioning of the robot, we're going to need it to turn around to get this next disc here. And we're going to need it to turn around without bumping into this blue disc here. So first we're going to have the robot drive in reverse just a little bit to give it some space. So let's get this drive for block and drag it out. And we are going to change this to reverse. And we don't need it to reverse for 200 millimeters. 100 should be just fine. Okay, so that'll give it a little space to then turn around and face the second disc. So I'm going to get another turn to heading block, sorry. And I don't want 90 degrees now. As we talked about before, the heading straight up to the top of the playground is 0. So I'm going to add 0 to my parameter here. All right, let's run it to make sure the robot has turned around and is facing the correct direction to pick up the second blue disc. What have we got? Yep, we are good to go. All right, so now all that's left is to have the robot repeat those behaviors 2 more times. So what we're going to do is go back into the control category and we are, let's scroll down a bit. We are going to get a repeat block. And it's another C-shaped loop block, and we are going to put it around all of the blocks that we have in our project. And let me just zoom out a tiny bit so you can see it a little bit better. All right, so now what's going to happen is that these blocks inside this repeat block are going to repeat the number of times we put into this parameter. We don't need it to repeat 10 times. We just need it to repeat 3 times. So we're going to change it, and now we're going to watch our project run and see if we can get all 3 of these blocks using sensor feedback. Okay, so here is the first repetition. Turning around. Repetition number 2. And here it goes, repetition number 3. Fantastic, we did it. We used sensor feedback to get all 3 of the blue discs into their correct blue goal. So we've done a great job moving all the blue discs into their correct goal, but what if now we need to move blue, red, and green discs? Elena will be back in the next part of this session to help you learn how to get discs of other colors into their correct goal using nested loops. See you back here soon.
Hello, my name is Elena and I am another one of your camp counselors for the VexCode VR Creativity and Coding Camp. And you just completed a challenge where you collected all 3 blue discs on the Disc Mover Challenge and moved them back to that blue goal. So as you were solving that challenge, you did something called nesting loops. So if you remember, loops are things like forever or repeat blocks or the repeat until block that have blocks that can go inside of the loop or underneath it. And that loop repeats until that condition is met. So until it repeats a certain number of times, until the repeat until has a condition met that's reported as true. However that condition is met, the blocks inside of that loop are going to continue running. So if we look back at that solution that you made, you can see here that we have loops that are nested together. So on the outside, we have our repeat loop. So this repeat 3 times. And inside of that loop, we have 2 other loops. So that's what I mean by nesting, is that one loop is inside of another loop. So here we have the repeat until that is inside of the repeat block. And then we have another repeat until that is inside that repeat block. So why do we care about nesting loops? Well, this helps us consolidate our project. It helps shrink it, make it easier to understand and easier to read. So that way, as you're repeating these commands, you know exactly where to go to fix certain behaviors. So we're going to apply all of this about nesting loops as we try a new challenge on the Disc Mover Playground. So previously what you did is your robot drove forward and collected each of these blue discs and brought them back to the blue goal. So you collected those 3 blue discs. Now what we are going to do is we're going to collect 1 disc of each color and bring it back to its goal. So we're going to get this blue disc, bring it back to the blue goal, move over to this get this first red disc, bring it back to the red goal, and then move over to our green area, grab the first green disc, and bring it back to the green goal. So what we can do is we can edit our project here and actually make it so that we can get that first behavior all set, just like we did before. So I'm going to get rid of this repeat block here. So I'm going to drag everything out because I don't want to repeat these commands. And we're going to set our robot to that slower speed to be more accurate. We're going to drive to the first disc. I'm just going to go ahead and remove the color here. We're going to pick up that disc, and then we're going to drive to the goal as part of that, and then drop the disc in the goal. So I'm going to go ahead and remove these blocks also. So now what we have, if I run this project, we have a very simple project that's going to drive our robot to pick up the first disc and bring it back to the goal, which is exactly what we're trying to do. Now we need to think about the behaviors to move our robot from the blue goal over to the red goal so that we can get lined up to pick up another disc. So let's go ahead and we're going to add some more comments. So let me go ahead and remove the blue from this one. Because if you think about it, everything that we're doing, driving forward, collecting the disc, driving back, dropping off the disc, those behaviors are going to be repeated for each color of disc. So we can make our project and set it up so that it can use these nesting loops or these multiple types of repeat loops. So the next thing we want to do is we're going to need to back up from this disc so we don't run into it. and then turn to face the next goal. So for that, we're going to need drivetrain commands. So we're going to want to drive in reverse. We don't need to drive in reverse very far, maybe just 100 millimeters. And then we want to turn this direction towards the next goal. So we've talked before about turn to heading a few different times, even earlier in this project. And if you remember, the heading for our robot to be towards this right direction is going to be 90 degrees. So that's our 90-degree heading. So we're going to turn to that heading. And let's go ahead and run this project and see what happens if our robot is going to face in the correct direction. So it's picked up the disc, it's bringing it back, it's going to drive in reverse, and now it's turned to face the red goal, which is exactly what we need it to do. So now we need to drive to the next goal and then turn to face the disc. And face the disc. So for this, we're going to drive forward. If you remember, each of these squares is 200 millimeters. So we've got 200, 400, 600, 800. So we should be able to drive forward 800 millimeters. And then we're going to use another turn to heading block to turn us towards that disc. So again, thinking back to our headings, this is going to be to heading 0, where it's facing back up at that original start location. So now we should be facing right towards this red disc. So let's reset. We'll run our project. Remember, we want to test things over and over again just so we can make sure that we're testing things frequently. We know what our robot's going to do. So it's moving to that next line, and now we are ready to go and pick up the next disc, which is our red disc. So if you remember, we're already repeating these same behaviors that we did before. So what we can do is we can go back to our control category, grab a repeat loop, and we can repeat all of these things to grab a disc, to drop it off, and turn to the next goal. Now, we don't want to repeat it 10 times. If you think about it, we have 1, 2, 3 discs, so we're just going to repeat this 3 times. And let's walk through this. So let's test it out, see what happens. You'll notice I did not put the set drive velocity block inside of the repeat loop, and that is because we only need to set that velocity 1 time. So otherwise it'll be set over and over, and that's just something we don't need to do. So we can leave that block at the very top. So now, as we go through, we can start to watch our robot perform these different behaviors, driving forward, moving to the next column here, so driving forward, and then it's starting through these behaviors again. As it goes through, you'll notice once we get to the green, it's going to start this loop over again, this repeat loop. It's driving forward to that disc. Now it's driving forward to the wall, but it's still going to drive in reverse and turn towards that next goal, and our robot's going to get stuck on the wall. Now, the robot getting stuck on the wall after picking up and moving the green disc is totally okay. There is a way to solve that, but it takes some more complicated coding methods. And right now we want to keep things simple and talk about our nested loops. So we're going to go ahead and say it's totally okay as long as the robot has moved each of those discs to the goal that matches that color, which is exactly what our robot did. So all of this was to talk again about nested loops. And this is the same kind of nesting we saw before. We have a repeat loop here. So when my project starts, it sets the velocity, and then it starts this repeat loop, which is going to run all of the blocks inside of it. We can tell what's inside of our repeat loop because of the orange bar all the way to the left, and that's going to tell us what's inside. So now the first thing it does is it's going to run the first loop. In this case, our first loop is saying, to drive forward until this condition is met, until the down eye being near an object is true. So it's going to constantly run through this loop here, checking the values until this is true, which is why our robot drives forward to that blue disc. We'll run the project while we're talking through it. So it's constantly checking this condition here. And as soon as that's true, it's moving to the next blocks in the stack. And then it's doing the same thing with this repeat until. It's going through, it's running the block inside as long as this is reporting as false. As soon as this block reports true, that front distance less than 100 millimeters, then it's going to move on out of this loop and on to the next block in the stack. And as soon as it's done, it goes back to the beginning of our repeat loop, and it happens again and again because we've nested those loops together. So now that we understand how to nest these loops and how to pick up discs of each color, your challenge, the Disc Mover Challenge, is to pick up all of the discs of each color and bring it back to its goal. So you're going to pick up the blue disc, bring it back. Pick up the second blue disc, bring it back. Pick up the third blue disc, bring it back. And then move to the reds and do the same thing again. And you'll go through that process until all 9 discs are collected in their matching colored goal. So go ahead, use everything that we've talked about with our nested loops, with those saved projects that you have, and solve the Disc Mover Challenge to move all of those discs back to the goal of their matching color. Congratulations on solving the Disc Mover Challenge. So let's go ahead and go through a sample solution together. Remember, just like always, this is just one way you could potentially solve the challenge, and yours may look different from mine, and that's totally okay. So I'm going to run the project while we talk about it. So my robot is being set to 25%, and you'll see I have multiple sets of nested loops. So I have one nest, this one that's on the inside, this repeat 3, that's for collecting all of the discs in a column. And then my bigger repeat is to do that 3 times. So all the blue discs, then all the red discs, then all the green discs. So if I go ahead and run this, we can see it's driving forward until it detects an object. And then it's driving back to the goal and turning around. Now this time I didn't reverse my robot or do anything like that, so it's going to run into the discs, which is something I could change if I wanted to edit my project again. You can see it's kind of knocking them around. That's okay, they're still inside the goal. So now it's going through this inside loop here, this repeat 3 loop. And now that it's met all 3 of those, it's true that it's done this 3 times. It's going to the outside, drives to the next goal, and then goes back inside of this repeat loop. So you can think about this like a multiplication problem. So this outside loop, 3, it means that we're going to repeat the inside loop 3 times 3 times. We're going to repeat this inside loop 9 times because we have 9 different discs. So you can actually do some cool math to figure out just how many times your robot is going to repeat the behaviors inside of an interior loop if you're using the repeat block. So now it's going through all of the greens. We've already repeated this outer loop twice, and it's on its third run through. It's going to collect these last couple green discs, and then I'll go ahead and stop the project so it doesn't run into the wall. Just because I know that I'm meeting the goal, which is collecting all of these discs as we go through. Let me scroll down so you can see the bottom of my project as well. and we'll go ahead and stop. So this project does take a little bit more time because it's picking up and moving these discs. But you can see how we've come up with all of these really complex and exciting behaviors for our robot just by combining the things that we've already learned. Congratulations again on solving the Disc Mover Challenge, and we will see you in another session. Thank you.